Good afternoon, everyone. Let's begin. I will start off with a picture of an engineering marvel like I do every week. And does anybody know where or what this is that's pictured on screen? Yeah?
Burj Khalifa in Dubai.
That's right, the Burj Khalifa in Dubai. It's the world's tallest building. And I should have written the specifications on there. I think it's more than 800 meters, which is awfully tall. I do a calculation in one of my classes where we go through and using something called the dry adiabatic lapse rate, calculate the temperature difference between the top and the bottom because air cools as you go up to the atmosphere. And it's actually, on average, 5 degrees Celsius cooler at the top of the building than it is at the bottom. So that's maybe one incentive to lift the top is a little bit cooler than the normal warm Dubai weather. Let's take a look at a couple of announcements and then I'll introduce our speakers for today. First of all, the concrete canoe team is still looking for help. They want people who can paddle, they want people who can lift and mix concrete or want to learn how to do any of those things. The meeting is Tuesday the 23rd at 6 p.m. and freshmen are definitely welcome and they'd love to have your participation. The other announcement is, like we do every week, there's a quiz that will cover the material that's discussed in today's lecture. That quiz will be available in probably about an hour after class concludes, and then it'll be open through 11 o'clock next Friday morning. So any questions about those two announcements? Okay, well, we're very fortunate to have two excellent speakers today. Dr. Richard McCormick is going to do the faculty introduction, and then our main speaker will be Jessica Meadows, who's a recent graduate of Marshall's program and works as an engineer at Special Metals. So I'll turn the time over to Dr. McCormick, and then Jessica can begin as soon as he's done speaking with his introduction. Dr. McCormick.
Thanks, Dr. Wade. I'm not going to take very much time because I'm sure you'd rather listen to Jessica than listen to me. My name's Rick McCormick. I've been at Marshall. I'm finishing up 12 years. Before that, I spent 28 and a half years at West Virginia Tech in Montgomery. Nearing the end of my career,
exactly how I want to do this. Here we go. Well, I'm Jessica Meadows, and like they said, I graduated about a year and a half ago. No, wasn't really a traditional student. I returned after having kids and stuff like that, so I'm a little older than most of you probably are. But they told me to just tell you a little bit about how my first year has gone. It's been a roller coaster. The first, why I chose engineering, I was always kind of pretty good at math. My dad, he worked construction, and I helped him some on odd jobs that he did, and I really enjoyed that. And then after we started rebuilding my house a couple of different times, expanding for my family, I decided that, you know, construction was really what I wanted to do, and engineering was the way to go about it. So I went ahead and enrolled here at Marshall because they finally had a program, which they hadn't had for lots of years. I returned to school in the summer of 2008, and while I was here, I was vice president of our SAME ASCE club for 2011 and 2012, and on that year I was also a big part of the concrete canoe, which they mentioned today. I highly recommend that you get involved in this. It's a lot of fun, you learn a lot. If for no other reason, you get to go out on Beach Fork and play in a concrete canoe at some point, hoping it doesn't break and everybody gets wet. And then in 2012, 2013 year, I was co-captain of our steel bridge team that went to nationals, which was really exciting for us. And I became a member of Theta Tau, which is trying to get its full membership, I think, as a fraternity soon. Then I graduated in May of 2013. So after graduation, apply, actually before graduation. Send out those resumes, try and apply to any job you can. I wanted to stay locally because I already had a family here. And after actually some networking opportunities that I had with local engineering groups, allowed me to interview for Special Metals, which is here in Huntington. It was originally began in 1922, which means it's very old, and it shows in our work. I had to repair a wall recently that I had to go back to 1920 drawings to find the wall that they had moved 4 times to find its structure. So it's had a lot of names over the years. It's been bought and sold. It was Inco Alloys International, International Nickel Company, Huntington Alloys, the nickel plant, a lot of people call it, and now we're Special Metals. It was purchased by Precision Cast Parts Corporation in 2006, and our engineering department, we're Special Metals HBE, which is Huntington, Bernal, and Elkhart facilities that we take care of. So if there's any problems, you know, you're in a car and driving for several hours to get to Indiana. I've not had to do that because I don't know enough yet, but. At Special Metals, we make high-performance nickel alloys. So we have non-magnetic materials, and we supply these different industries. I remember one of my coworkers telling me that there was a big sheet of one of our products coming through, and a man from China there saying, these are going to be laptops someday. So our products go into a lot of specialized companies, and PCC owns a lot of the manufacturers that our core product goes into. We're pretty specialized in that we can make over 100 different alloys. They are high heat resistance, hardness, and acid resistance. And like I said, we're bulk production, so we make large plate, billets and bars, wire, things that other companies take and then they reprocess into gears or whatever they happen to need them for. This is a bunch of boring information about the variety of sizes that we have for the different bulk products that we make. I know you don't want me to read that, so I'm not going to. This is kind of our workflow for how our products are made. We have several different types of furnaces: electric arc, argon, oxygen reactors, vacuum induction melting, air induction melting. We also have powder metallurgy that is being developed right now. We used to do, and now they're trying to redevelop a new material for a new process. All of these things, they go into either, you know, melting and remelting and reheating, annealing to produce the different billets, bars, rods, plates, wire, and things that we make. So the role of an engineer at Special Metals. In our engineering department, we only have 2 electricals, 4 mechanicals, and their 1 civil. They said they hadn't had a civil engineer there for over 20 years. But they are a manufacturer. They need a lot of mechanical and electrical engineers, but their buildings are starting to fall apart now, so they decided that maybe somebody with steel and concrete experience might be necessary. But throughout the plant, there are also engineers. There are our department supervisors, maintenance managers. They don't necessarily work in the engineering department, but it's really important for them to have the knowledge and the capability to use their engineering skills to keep production or improve timing or whatever we're looking for on any given day, which changes every day. Where I started with their company is as a civil engineer. For my first quarter of working there, it was a lot of very boring and mundane things. I felt like I wasn't really doing much of a job. I had to learn plant procedures and protocols, hot work permitting, safety rules, OSHA regulations, the processes you have to go through to get all that paperwork done, and what's going to happen to you if you don't. I also got to tag along on some of the large projects that my boss was going through. He was putting in a new tree pan machine at the Bernal plant, and they were in the final stages of that. So I got to review the drawings for that, make sure that it was actually as-built drawings, that they didn't have a pipe in the wrong spot or pumps that were mislabeled. And I had to learn CAD. One of the bad things that I've noticed here at Marshall is they use MicroStation. And it's a great program. I learned how to do 3D during the Steel Bridge competition, and it was really interesting, but a large portion of the rest of the world uses CAD. So even though the university doesn't require you to learn CAD, I suggest you do. There's a lot of free online tools for you to do that, and like with everything, it's practice, practice, practice. Okay, about the second quarter of my year there, I assisted other engineers with their projects, more drawing of what they had already, they would describe to me what they'd done, and I'd create drawings, documenting, scanning files from engineering companies that had sent in their designs. Because we're so short-staffed, we don't do a whole lot of our own design. And research, like I said, it's a company from 1920, so it takes a long time to find what you're looking for sometimes. In the third quarter, they started letting me design some things. So some of the smaller projects that I got to do were window alterations. They had fallen apart windows. They decided to board up and put fans in, so I got to design a little steel structure for the fan to mount to. And then I did some stiff backs, which are lifting devices that they use with their cranes. They had one that was failing, and so I had to redesign one to fix that problem. And then they had another one that just needed to be able to have more capacity. We had 36-inch wide plate and 48-inch wide plate, and they didn't want to have to keep changing their stiff back, so I created one that was transition. And then I got to do that building alteration I was talking about. We have large machinery. Up there in that top picture you can see this giant truck that carries slag in and out of our melt shop, and if they're not real careful, they end up hitting things. So what you'll see right here is a wind wall column. They have bent it, sheared the bolts, knocked it off its foundation completely, bent the headers, tore the siding off the wall. And right here, if you'll look, that is like where they're supposed to break the slag pots, and that is after 3 months. They installed that new with 12-foot concrete right in here, and like 1/4-inch steel, 1/2-inch steel, something like that, and they'd torn it up in 3 months. So this is the kind of heavy machinery and damage that we try and deal with every day. So when they talk about over-designing and your factors of safety in a situation like this in a factory, you've got to like ×6, because they'll tear it up no matter what. So these were the repairs. Like I said, we don't do a lot of our own design, and since I am not a PE, I had to go to a consulting firm, and they designed a solution for our steel. So the top picture will show you the new steel that they put in. We widened the doorway, put in some headers for the column support here, and then replaced the column from here down. And then here's the finished product. And if you'll notice, we put in 24-inch round concrete-filled ballers to protect our structure now. Hopefully they won't take those out. Then going into the fourth quarter, they started giving me bigger things. This is our pickle house, and inside the pickle house, it's kind of a unique building. It's got an inside-out structure. The structural steel is on the outside, and what you can see on the inside is roof ceiling. It's a ceiling that was placed for roof loads. So that's to protect a structural steel, and what it's made of is galveston, which is not environmentally friendly, and we cannot replace it with that. My task was to find a suitable solution to replace this roof, but in the middle of trying to figure that out, we found out that our girders were failing horribly, and our cranes weren't functioning, and they were going to shut our pickle house down, which every bit of our product, round and long, goes through there. So we had 7 days to replace the girders in a 280-foot building. And so it was a 24-hour outage. Me and one of my coworkers, Jacob, took 12-hour shifts for 7 days on a crazy, crazy, crazy trip. I don't know that I really liked it all that much. But what I found out was that as-built drawings are very important, because when trying to prepare this project, we went from the drawings that we had from when it was built, and somewhere between 1980 and now, they increased the crane rail to 60-pound rail. And so we had ordered 40-pound rail. So immediate changes had to be made, and materials brought in to make our crane wheels fit the new rail that we had put in. Another one I just started actually is secondary containment. I'm trying to get funding for that. The new regulations for West Virginia, because of the spills in Charleston that caused all the water to be out there last summer, or whenever that was, last winter, has caused us to have to upgrade our containment areas. And what we have is a used oil tank farm in which we have like 5 tanks that are kind of interconnected. It used to be a cracker system that would reprocess oil and we could use it. It's not used that way anymore, just used oil is stored there, but because the containment isn't proper, we have to fix it. So what we're going to have to do is raise the containment about 1 foot all the way around, and as you can see with all the piping and the valving, we're going to have to change the piping in that too. So again, I asked a local consultant to give their stamp on a drawing with the ideas that I came up with. Then this past May, they decided that they would ask me to start also handling the capital appropriation side of our business. For this part of my job, it is to request funding for all the large projects, which would be my oil containment or even the pickle house girders. That was another one. But now I get to learn about all of the major projects that go in our plant. The newest one that's going on is the 23-inch mill refurbishment. So my coworker Charlie Bolt, he knows a lot about this, and so he's been trying to educate me on the process of how they would go about fixing it, what's wrong with it, what parts we need, where they're going to come from, how long it takes to get them, and then I have to compile a large proposal for the corporate level to give us the funding that we need for these projects. So I also have to track spending all the ones that get approved, and I have to track scheduling and project completion. And I have to give explanations for why we're not going to be completing on time. So that's a little stressful. And then I got to do that on top of all the little things. As our engineering department that handles everything that goes on in these 3 plants, even if it's not a major project that requires millions of dollars and a week outage, people are coming to us and they're like, hey, I got a problem, can you fix it? So right now I have piping flow meter alterations for that ball mill project that they're researching. It used to be retrofitted for nitrogen, and now it has argon, and so they need new flow meters and new piping because they have to have it fit right for their research. Let's see what else is on here. Contractor timesheets, that can be really, really cumbersome, because when you have a 7-day outage, you got 16 men for 2 shifts, and you weren't there the whole time, but you've got to make sure that all the hours add up, and they didn't have an extra crane on there that they're trying to slip in some extra charges for or something like that. That's part of engineering too. You don't think about it, you just think about the calculations, figure out the problem, solve it, a lot of times if you're part of a construction company or even this plant, you know, you've got to deal with the money too. So kind of have to be a little bit of an accountant, I'm learning. I had to do a collection lid for the ball mill. That was kind of fun, actually. Just checking the piping under where our concrete slab is going to be to make sure we don't hit anything, water mains, which way does it flow, how can we reroute it, that kind of stuff, just to help maintenance out with a problem that they might need to do. As for what I would have done differently, Dr. Wade asked what I might have done. I would have done more internships. During my time, you know, I had kids and everything, so I didn't put a lot of importance on that until like my last summer. Before I graduated, I was with the DOH for one summer. It was kind of a joke. I just sat out by the road on night shift and watched men work, but I would have done something more meaningful. Maybe something that did research with the faculty here. They do a lot of that, and so you'll get to see if maybe research is your thing, because I don't think research is my thing. I have to do a lot of it at work, but I do not like digging through files and digging through drawings and trying to find that one little piece of information that I need. I enjoyed field work. Like I said, I was on the concrete canoe team and the steel bridge team, and getting my hands dirty, that was really what I like to do. So when I can be out in the field and actually help them with a problem, that's what I like the best. But also, if design is your thing, I have some friends that went into consulting companies and they see a problem, they go look at it one time, they come back, do their drawings, do their calculations, and then they're really done with it. And if that's what you like, then that's what you like. I don't think I would either like that either. I like being in the field. Another thing I would have done was more project management, because like I said, it's not just calculating. You got to be able to manage a lot of different things that you never really thought about. Timing, getting your quotes in on time, leaving yourself enough time. You think that you'll be able to get done, you know, within 2 months, but if they don't get you your quotes and you don't, you know, you just, one thing holding you up is going to push the whole thing back ×4. So business management would also be helpful. Now that I'm in this capital appropriations bit, I need to be an accountant as well. So I'm actually thinking I might go back and get my MBA. Might be useful someday, but I'm still deciding on that one. I'm kind of done with school for now. So my advice for new students, I think I'm probably talking too fast for Dr. Waite's liking, but I would, you know, definitely you need to get involved in the clubs. You'll meet people, and like they said, you got to do your homework, you got to work hard, and if there's somebody else with you that can help you along with it, that's the great way to do it. Dr. Waite said you guys have 113 students. We had about 75. We only graduated with like 28. You're going to find your niche, stick with it, stick together, help each other, and you'll do great. Yeah, the closest thing I got to real world was the steel bridge, because we had to deal with suppliers, and then suppliers canceling on us and getting a new supplier. We had to deal with fabricators that then backed out, and then the timing got pushed back, and then it came spring break, and me and my co-captain were in a fabricator's shop welding it together. We broke it twice, you know, staying there till midnight to get it fixed on time. You know, that was the best real world thing that I had going here at college. So definitely get involved in those. And also you have to know when to say no. You can only take on too much. I remember one semester I had 21 hours. I think it was 3 labs. I was vice president of the ASCE chapter doing the concrete canoe, and I thought I was going to crack, you know. So at the end, the next semester, I made sure that I didn't overload myself. So you have to know what your limits are. Push yourself always, but don't push yourself too far, because you'll get overwhelmed pretty fast sometimes. But I'm still working on that one, because I can't seem to tell people no at work either. Advice to the faculty. This is probably not going to help you guys any, but if you want a good experience, I would, for your senior design and things like that, you might consider changing the scope a couple times during their design, because that happens all the time. You think you're 80% finished with a project, and then somebody comes and says, oh wait, I forgot. We need this. Or, oh, I just found we have a water line in the way. And you have to change it last minute, and then, but still get it done on time. So it's frustrating, but it happens all the time. Another thing I've noticed and run into is random urgent questions that nobody can wait on the answer for. So if you guys want to just pass the guys in the hallway and say, hey, do you know what that thing that I talked about 3 months ago to you is all about? See, get them the nervous, oh my gosh, I can't remember what you're talking about, and figure it out real fast and get you an answer. Yeah, stress that engineering is not all design, calculation, or problem solving. It's documentation. A lot of times, since we have drawings, we have over 300,000 drawings of the different equipment and parts of our plant, and I will spend 2 days sometimes just trying to find what I'm looking for. So clear documentation, writing down your thought processes, those are really important in the real world, because I don't know why people change the crane girders from, 60-pound rail to 40-pound rail, and I'll never know why. I don't know when they did it, I don't know how they did it, but it happened, and it hit me in the middle of a 7-day outage that could have cost millions of dollars to the company. So documentation is very important. And also, having students be the ones to give a clear description of the problem and the solution that they would like to see happen. What I've run into is whenever I have contractors come in that I want them to, fix something for me, I know in my head what I want them to do, but I don't really know exactly how to convey it to them clearly. And so when you have 3 different contractors in, all supposed to be quoting the same job, but they didn't necessarily understand what you said to them the same way, you'll have quotes ranging from $200,000 to $450,000 on the same job, which you don't know if any of them are crap or one of them is just really good. So maybe having the students be the ones to describe the problem is a good idea. So I guess that's it for me. I'm kind of early. If you guys have any questions, go ahead and ask. I'm pretty much an open book.
Thanks, Jessica. We do have a few minutes for questions, and then I have something I wasn't sure whether we'd have time to take a look at, but I'd like to thank Jessica for coming to speak to us today. She's given you a lot of really good advice, so let's give her a round of applause. Okay, so any questions from you on her experiences at Special Metals, or anything you'd like to know about getting an internship, or the information that she covered today?
Yeah, we had 3 students in engineering this summer. They had several of them in quality control, and I think health and safety had several of them. So yeah. Well, currently we have 1 student that remained. He's coming just for a few hours twice a week to keep his foot in the door and help out with one of the projects he was already working on this summer. I can get with HR and have them send some information to Dr. Waite, because I think they may be doing year-round and periodically when funding is available.
Do you remember when the summer cycle started, when the advertisement went out for that? Do you have any sense?
I have no idea. I didn't even know we were getting interns till they were there. I'm like, oh wow, we have help. Yeah, we are the patent holders for a lot of those. Inconel, Monel.
What's Monel?
I'm not a metallurgist or a materials guy.
It's like nickel, but it's mine.
Yeah.
That explains it.
It's got a lot of different stuff in it. I've read up on it when I first got there, but there's, like I said, over 100 of them. I'm not sure which ones have what in them.
Other questions? All right, thanks, Jessica.
Thanks.
Okay, so what I was wanting to show you is a video that I came across, and actually, ironically, it probably applies to you less than it applies to some of the other students that I have. Pull it up, and then I'll give you a little bit of background.
Beth will probably post it on Facebook or something.
my juniors and seniors. So I wanted to show you kind of a funny video that I noticed this morning that gives you a few pointers on composing emails to faculty members. And so let me see if this will play. There it is. All right.
Missing class from Cartman Rules 99 at yahoo.com. Hey! Hey yourself. Probably not the best way to start an email to a professor for the first time. You may want to put maybe the professor's name here, a
Saying some pretty funny stuff. Let's see if it's just muted here. It seems like maybe the audio's not working. All right, well, what I'm going to do is I'm going to provide a link to this email for you to watch it, and I'll make sure to include a question or two in the quiz to give you an incentive to watch it. Basically, this math professor is just going through, and even though he's not an English professor, going through and explaining some of the mistakes that the student made in composing an email. For example, saying what his name is, Cartman Rules 99. The professor had no idea who the student was, and there are a few assumptions and funny things in this message that the student sent to the professor. I'm sorry we can't watch it together. The audio doesn't seem to be working for some reason. But anyways, I'll send you an email with this link so that you can watch it. It's a brief video, only 3 minutes long. Remember that the quiz will be due by 11 o'clock next Friday, and I hope you have a great weekend. Bye-bye.